Hello and welcome to Chapter 6, Section 6. Today we're talking about solving systems of inequalities. Again, we're going to start with an ordered pair. So as we stick 2 in for x and 1 in for y, does it work? Well, negative 2 plus 4 is going to give us 2, and 1 is smaller than 2, so this one works. 1 and 2. 1 is smaller than or equal to 3. This one works. So 2 comma 1 is a solution to our system here. How about this one? Is 2 comma 0 a solution to this system? So we're going to stick 0 and 2 in for y and x. And is 0 larger than 4? No. How about this one? 0 smaller than 2 plus 1 is 0 smaller than 3. It works here, but it doesn't work here, so it's not a solution to our system. It's not the place where these two areas meet. Now, with a system of inequalities, you're going to need to graph them because we're not solving for lines, we're solving for areas. So we need to show that where the areas overlap. You're going to graph both lines and you're going to shade them. And where the shading intersects is the solution to the system. Let me show you what that means. So these questions are going to ask us to graph both of the inequalities, and we're going to give 2 ordered pairs that are solutions and 2 that are not solutions. So we're going to get 2 inequalities. And we're going to have to start by graphing the lines that they represent and then figure out the areas. So I'm going to say 4y is negative 8x plus 12, and I'm going to divide everything by 4, and y is smaller than or equal to negative 2 plus 3, and this one is already in that format. So this line is a solid line because it's greater than or equal to. I'm going to start at the 3, 1, 2, 3, and I'm going to go down 2 and over 1, down 2 and over 1, and that's my line. And it's a solid line. Now, in order to figure out the area that we're talking about, I want to find out, does 0, 0 work? Is 0, 0 a part of it? Because it's either going to be all of this side or it's going to be all of this side of the line. So I'm going to stick 0, 0 in to see if this is part of it or not. So, whoops, I forgot my x. So I'm going to stick 0 in for y and 0 in for x, which just leaves the 3 here. And yes, 0 is smaller than or equal to 3. So I know that I'm talking about this entire side of the graph. So this line, inequality, and this side of the graph. Then I'm going to look at the other one. Y is larger than 1/2 x minus 2. I'm going to start at minus 2, and I'm going to go up 1 over 2 and up 1 over 2. And I'm going to draw, whoops, and this is a dotted line. Because it's not equal to, so it does not include the line. Now, does this include 0 and 0? Is 0 greater than negative 2? Yes, it is. So it also includes this spot, so it's this. Now, that means that where these two intersect, this area right here, this is the solution to our inequality. So I'm going to name 2 ordered pairs that are in here. So we could pick some spots where both areas overlap in this region. So we can pick, let's say, negative 2, 0, and something big like negative 10, 0. We could pick something up here like negative 1, 1, or something over here like negative 8, 1, something like that. And when we're choosing 2 that are not solutions, we want to be somewhere over here. It could be here and it could be here because this, solves this one but not that one, and vice versa. You could also pick 5, 0, 10, 1, 17, negative 2, something like that. So you're going to give ordered pairs that are in this region and then ordered pairs that are not in this region, okay? Try check it out, numbers 1 and 2 on pages 435 and 436 to see how you do with graphing inequalities, finding the ordered pairs that are solutions and are not solutions. Pause here and come back when you're done. So for check it out, number 1, is 0, 1 a solution to this equation? Yes, it works for both of them. Is 0, 0 a solution to this system of inequalities? No, but it does not work here, though it does work here. For number 2, we have these two inequalities in a system. So I graphed both of the inequality lines and I found the regions, and this is where they overlap here. So I found 2 that work, and you can find any 2 that are in this section, and then I found 2 over here that do not work. Similarly, I graphed these 2 lines here, these inequalities, and I graphed the areas where they work, and they overlap in this region here. So these work and these do not, and again, you can find any spot that is in this section, okay? What happens if you have parallel lines? Well, parallel lines have the same slope. You can see here I've got 2's in the m spot of y equals mx plus b as a coefficient of our x. So these are going to go up and over the same way. They're just going to start in a different place, which means that these 2 lines are going to be parallel. These 2 lines have a slope of 1, so they're going to be parallel because they start in a different place. These 2 lines have a slope of negative 3, but they start in a different place, so they're going to be parallel. Now, the question is, do these overlap? Well, as lines, they do not, but perhaps as areas, they do, and you have to figure that out. So, we're going to start by graphing. We're going to start at negative 3, and we're going to go up 2 and over 1, up 2 and over 1, and we're going to graph, and it's a dotted line. I always forget that part. And this one we're going to start at positive 2, and we're going to go up 2 and over 1, up 2 and over 1. So this is a dotted line. So these 2 lines are parallel. Now the question is, what regions are we talking about? So we're going to try 0, 0 for both of them to see if that works. Is 0 smaller than negative 3? No, it's not. So the negative 3 line does not include 0, 0, so that we shade this way. And here is 0, 0. Is 0 larger than 2? No, it's not. So this one gets shaded this way, and this system has no solution because it does not have any points that are in common. What about the third one? We're going to stick zeros in here. Whoops, we got to solve it. Let's graph it first. We're going to start at negative 2. And we're going to go down 3 and over 1, down 3 and over 1. So here, and it's a solid line. This is our first line. And here we start at positive 4. And we're going to go down 3 and over 1. And this is going to be our line here. Kind of. I'm lousy at lines today. And we're going to try 0, 0, see if that works in the middle there. Is 0 smaller than negative 2? No. So the negative 2 line does not include this, so it's this region. And here, 0, 0, is 0 smaller than 4? Yes. So this does include this region. So again, where the 2 regions overlap, any point in here is a solution to this system. There's one more example they'd like to show you. I am slightly altering one of these so that you can have the a different type of example. And I've switched these. So again, we've got parallel lines because the slope is the same, but the spot where they start is different. We're going to start at -3, and we're going to go up 2 and over 1. We're going this slope, up 2 and over 1, and it's a dotted line. Oh my gosh. And here we start at +2, and we go up 2 and over 1, up 2 and over 1, and it's also a dotted line. And we're going to try 0, 0 to see if that section works. Is 0 greater than -3? Yes. So the -3 one includes 0, 0. And here is 0 smaller than +2? Yes. So the +2 line also includes 0, 0. So where they overlap is just in between these two lines. Now realize it's not on the line because it does not equal the line. But anything in between the two lines will be a solution to your system. Okay? Check it out, number 3 on the top of page 437. They have 3 for you to try out. Give it a shot, pause here, come back when you're done. And for 3A, the regions both point outward, so there's no solution because there's no place that they overlap. For B, they both point inward, which means they overlap in between, and because it's equal to as well, they're solid lines, so the ones on the line also count. And for C, they overlap on this side over here. Okay? On to the business application.